Hello everyone. Am I audible?
Yes, ma'am.
Okay. So I think we should wait for. Okay, it's already 5. Okay, I think I should start my presentation. So hello everyone. Basically today there is a different thing I will do right now. Okay, just a minute. Someone is coming. Hmm. So basically today what we will do, uh, today is the week 5 assignment 5 course, but today we are not discussing about any question and answer. Basically one of our students who was just asking last class about the direct and compound reaction, nuclear reaction. So today I will do basically a simple theory based class it will be, and in the theory based class we will do something basic about the nuclear direct as well as compound reaction. In today's class there will be no question and answer session, only the theory will be there, and if you people will understand then it will be very good, and if there will be any question in between that theory you can ask me anywhere. And basically it may be a useful tool for the students who are going to who are going to participate in any competitive exam like NET, GATE and all these things. So it will be like obviously very important for these people, so I thought that it will be very good for you. So that's why I am just talking something more about nuclear reactions today, instead of taking all the question and answer session. So today I think there is someone. Okay, no. Oh, someone raised a hand.
Actually, ma'am, yes, sir. Actually, I am that student.
Okay. Yeah, actually, like I forget that name, so sorry for that. Yeah. So you wanted last class that you just wanted to specify that what is basically direct and what is basically the compound reaction. So
Yes, yes.
yeah, for you people, not only you only, for all the students I am talking about something more about nuclear reaction, and specifically not all the nuclear reaction I am talking about. Specifically I will talk about direct and compound nuclear reaction. So maybe
Okay.
it will be helpful for you people. So okay, let's start. So there will be, okay, I'm writing something here. I will be starting from the very basic of nuclear reaction. I think you all people may or may not be understand, like may or may not know about the nuclear reaction. So that's why I am starting very from the very basic of the nuclear reaction. So basically, what is basically nuclear reaction is the nuclear reaction. Okay, someone is coming. Yeah. So nuclear reaction. If I write here, nuclear reaction, Basically in one line, if I write a nuclear reaction, it will be like that: x, x, y, sorry, x, x, y, and y. So this will be a nuclear reaction expression. But what does it mean? It means that x plus x going to y plus y. This is the nuclear reaction expression. So what is x here and what is small x, small y, and small capital Y represents? So sorry. Capital Y. So here the capital X is represent the target nucleus, okay, and small x is a projectile, small y is a outgoing particle. Okay, someone has come. And capital Y is the residual nucleus. So what are these actually? So in a nuclear reaction, let's say there is a target nucleus which is very heavy. Like in most of the cases, the X is very heavy, so that's why it is written in capital X. You can say like that. And here a small x is coming to hit that target nucleus, and as a result, as a product, there will be one small y means it's like a outgoing particle means it may be a elementary particle, it may be a alpha particle, gamma, photon, and all these things. And what else will be there? Some one heavy nucleus will be produced. That heavy nucleus we are talking about in capital Y notation, and it may be as known as a residual nucleus. So this residual, so there is a spelling residual, okay. So residual nucleus. So this in that nuclear reaction, the things are like that. Here the two, I mean incoming particle will be 2 and outgoing particle will be 2, like in a very general and in a very simple way I am talking. So here capital X was a very heavy nucleus, and small x is a projectile which will come to hit the target, and the outgoing particle will be small y and capital Y. Small y will be outgoing, let's say outgoing gamma, X-ray, alpha particle, proton, neutron, and all these things. And capital Y, what it will be? It will be a residual nucleus with let's say very high mass, just comparable to capital X. So this is the main thing for nuclear reaction. Now depending on the nature of the nuclear reaction, there are so many types of nuclear reaction. We can classify nuclear reaction as a let's say 9 types. So I am talking about these 9 types very shortly, and after that we will go to the our main topic, which is direct and compound reaction. So coming to the first case of nuclear reaction, like you can classify the nuclear reaction in many types, but in general how many types it will be, I am just talking about. The first one will be, let's say, elastic nuclear reaction. So in elastic nuclear reaction, what will be like that x, and x. I'm using that notation. I'm using this notation throughout the talk. I will be using that notation, that x, y. So here basically x, capital X, and small x is the incoming like initial particle, and the final particle will be small y and capital Y. So just taking that notation in mind, I am writing elastic nuclear reaction as like that, xx. What it means like that? Like it means that our incoming particle, like initial particle and final particle, will be same. Like the target nucleus and projectile will be the same as the outgoing particle and residual nucleus, and there will be like that's called a elastic scattering. In that elastic scattering, in elastic reaction, in elastic nuclear reaction, what will be? Mm, hmm. In elastic scattering, what will be there? Basically, as I already told you, that there is no change in outgoing particle, and also the energy and angular momentum of that outgoing particles will be the same as incoming particles. So this is basically a elastic scattering. And the second will be, sorry, the second will be, let's say, inelastic. So what is inelastic? The inelastic will be like that, x will be there, then x and y, and let's say x star will be there. So star is basically meaning that excited state of capital X. Okay. So here the main difference is that, and also here y equals to x. So that means if I write a here inelastic scattering in the sense like that, then what basically does means it that the incoming particle was like initial particle was the target nucleus as x, capital X, and projectile as small x, and as an outgoing particle, the small outgoing particle is the same as the projectile, and the residual nucleus has the same nature, but like it's in a different excited state. Like as x, capital X is in a ground state, but x star is in another excited state. So in inelastic scattering, the main difference between elastic and inelastic is that in that inelastic scattering, the energy of the projectile will be different, like it will be reduced, and as a result the target nucleus will get more energy to give to take part in the excited state of its same energy level, its nucleus. Like x will be there, but it will be in excited state. This is the main difference between elastic and inelastic. So, and after that I can write here as 3. Okay, someone is there. Okay, someone raised a hand. You can talk, like just take unmute yourself, you can talk. No need of taking a raised
Okay,
hand.
okay. Uh,
Actually, I can't see that who will take a
okay.
raised hand and all these things, so you can just talk. Okay.
Yeah, I have a question about the projectile in this sense for the scattering.
Yeah, sorry.
Uh, Projectile. What is the projectile
Okay.
in the scattering process? What is
Okay.
the meaning?
Okay. What is the meaning of projectile? Yeah, sure. So projectile is basically here it is denoted by small x. Okay, the projectile is basically a very similar as the outgoing particle. I was talking about small y. So projectile is maybe a neutron, a proton, or a high energy alpha particle, or a gamma means a photon. So that type of particles which are very small, and it may be one nucleon will be there, it may be a very small nucleus, like alpha particle, you know that in the alpha particle 2 4 is there. So it is a very small nucleus, then alpha particle may be a projectile. Otherwise proton may be a projectile, neutron may be a projectile, gamma photon is also a projectile. So projectile is basically a very small particle which can hit the target, and in the target it's a like, in general we are talking about target as a very heavy nucleus, very heavy particle, something like that. But small x is a very small particle, it may be proton, neutron, gamma, alpha particle, and all these things. Okay.
Okay. I was thinking the projectile like so.
You were thinking about?
Uh, Nucleus content, during scattering process, it has projectile curve. Projectile. Curve. What is the meaning? What is the meaning? What is the meaning?
Okay.
Projectile. Projectile. Curve. What is the meaning? 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 What is the me was thinking.
Projectile, I can't hear, like, sorry. Uh,
Basically, he's saying the projectile motion.
Oh, no, 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 not projectile motion. Sorry, sorry. No, no, it is not a projectile motion. It is a projectile means a particle. Okay, it's a name. It's a nomenclature. You can talk about that. Like, it's a name that a residual nucleus, target nucleus,
Exactly.
projectile, something like that. It's a name. Okay. So projectile is like a particle which will be a very small in mass and very small in size, you can say, and it will be a very small energy or high energy. Obviously, it may be depend on which type of nuclear reaction we are talking, but it obviously not a projectile motion. Okay, so it's a some
Yes,
small
yes, yes,
particle.
ma'am. Okay.
Hmm?
Okay, okay.
Okay, okay. Actually, I
Yes,
can't
ma'am.
hear you. So if you will talk, talk a little bit louder. Okay. Sorry to say. Okay. So coming to the
Same.
third one. So here the elastic and inelastic scattering, and then the third one, like I'm just talking about a very little description. The third one will be radiative capture. Okay, radiative. So in radiative capture, what will be there? It's basically a example of a compound reaction. So I am writing here it like that: x y, then let's say y star, and y star means, as I already told you, star means it's in a high excited state. It is not in a ground state. Okay, so y star, so it may be possible that x plus x, it will come as y plus y star. Now if y star is in a excited state, it may decay to another particle like gamma, or let's say z. So this type of things may happen in radiative capture. So in that y star is basically very near about a compound nucleus. I will talk about what is basically a compound nucleus is, but the radiative capture reaction may be an example of compound nucleus compound reaction, where y star can also decay into another two particle means, let's say one gamma, and if it will decay at a gamma, and then it will be y again, or maybe let's say alpha particle plus z, something like that. So that means in radiative capture, x plus x will be there and y plus y star will be there. This y star can decay in another particle. So this is a radiative capture. And then I am talking about the fourth one. The fourth one is nothing but many body decay. So in many body decay, what is there? Many body decay means, I am just writing the expression here: x y1 y2 y3 dot dot dot, and then y. So you can just compare with this nuclear expression, that what does it mean. It means that x plus x will give us y1 y2 y3 y plus dot dot dot, maybe some more particle will be there. So basically many body decay is nothing but a generalization of a two body decay. So many body decay means we can have as a outgoing particle two, not only two particles, there will be 2 3 4 5 6, there are so many particles. And the many body decay, when it will be, when the energy of that small x will be very large. If it will be very large, then it may decay in a number of particles as an outgoing particle. So this is like a example for many body decay. Now coming to the fifth one. The fifth one is photo disintegration. Photo disintegration. So what is photo disintegration? In that photo disintegration, instead of x here, there will be a gamma. Okay, and this type of thing will be there. So photo disintegration, photo means obviously the photon. So photon will disintegrate into another particle. This is the example for photo disintegration reaction. This is another nuclear reaction, obviously. And the sixth one may be nuclear fission. Nuclear fission. I think you all heard about what is nuclear fission and nuclear fusion, but right now nuclear fission I am talking. In the nuclear fission, what will be here, that x, y and y, but here y and y will be in comparable size. Comparable size. And it may be possible when there will be a radioactive nuclei, or like let's say uranium. So in uranium, the x will be as a uranium, and let's say small x will be like neutron. So if I heat uranium with a neutron, then there will be two outgoing particle with the same comparable size, or comparable size. This is known as the nuclear fission. Then seventh one. In that seventh one, it may be that elementary particle reaction. So in that elementary particle reaction, what will be, let's say that same expression will be there, but in between all the things, like it may be possible that a small x, small y will be proton or neutron, something like that. So what does it mean? And also it will be like only one alpha particle. So elementary particle means in each and like any of the steps of the nuclear reaction, one elementary particle will produce. Let's say electron will be produced in that outgoing particle, then it will be a elementary particle reaction. Electron is elementary particle. So in any step of that nuclear reaction, if one or more than elementary particle will be involved, then that type of reaction we will call as elementary particle reaction. So these things are very simple. And then heavy ion reaction. So heavy ion reaction means what? Heavy ion reaction. So what is basically heavy ion reaction? So heavy ion reaction is like I am talking about one example, so that it will be very good for you all people. Let's see that type of example in A. So here it is boron is 10, oxygen is 16, and helium is 4, and sodium is 22. So here in that reaction, what it is does basically, the projectile is not a very small particle. Like as I already told you, the projectile, most of the cases projectile will be proton, neutron, alpha particle, and all photon and all these things. But it may be possible that projectile will be a very heavy nucleus. Let's say oxygen obviously have a very large mass and all these things. So heavy ion reaction means the projectile will be as a heavy thing. Like heavy thing means it will be oxygen, it will be neon, and all these things. If this type of reaction will be there, then we can say like that, okay, it is a heavy ion reaction. So these type of reactions are there, and also there are so many different types of nuclear reactions, but I am talking about only 8 or 9 types here. So just now coming to the main theme of our today's lecture, what is direct and the compound nuclear reaction. So coming to the direct at first, because obviously direct is at the very first level. So direct reaction. Okay, so direct reaction. What is direct reaction? Direct reaction means some properties of direct reaction is like that. For any direct reaction, we have to have our projectile with a very high energy, like high energy X. Just note down all the notations here carefully. Basically small x is projectile I am using, capital X is for target nucleus, small y for that outgoing small particle, and capital Y for residual nucleus. So just keep in mind that all the notations I am using throughout the lecture, that small x is for projectile, capital X is for target nucleus, small y is for outgoing small particle and capital Y is for residual nucleus. So these we will be taking into account. So if I write here high energy small x, that means to happen a direct reaction, our projectile should have a high energy. Now the second condition is that it will be take place at a higher energy, as I already told you, and the condition is like that 10 to the power minus 21 second will be the nuclear time. Like nuclear reaction time will be very small, 10 to the power minus 21 second. What does it mean? It means that one target nucleus is there and projectile is here. So one projectile will come and just hit the particle, hit the target nucleus and come back, or it will absorb and all these things. But all the process will be in between of 10 to the power minus 21 second. That means it will be a very short term process. This is the second property of direct reaction. So let's take two example of direct reaction. So I am taking all the things with a very simple notation. If you people have any problem in any step, you can just unmute yourself and ask me. The third condition is that example. Let's take an example of that direct reaction, then it will be very good to understand. One type
Hello,
of
ma'am. Please, please repeat the direct reaction compound because I have left the network.
sorry, I can't hear. Hello.
Hello, ma'am. Please repeat the direct reaction compound explanation.
Could you?
Uh, Reaction compound. Please repeat the direct reaction compound.
Can you please write in the chat box? Like I can't hear you properly. Sorry, it may be my internet connection problem or your, I don't know.
Yeah, he's asking for the re-explanation of direct reactions.
Okay, re-explanation of direction. Yeah, I think my internet connection is okay, because I am listening Dr. Muhammad's voice very clearly, but I don't know. Okay, whatever it is. So just he was just asking that re-explanation of direct reaction, right? Yes.
Yeah, exactly.
Okay. Okay, so in that direct reaction, like I am not talking about the a definition of direct reaction right now. I am just talking about the properties of direct reaction. Okay, if you can tell that what is basically the definition of a direct reaction. Direct reaction is nothing but a reaction which will be done as a direct thing. So direct thing means obviously it will be come from the name itself. The direct reaction means it will just give a example that one target nucleus will be there and projectile will be in other side, and projectile will hit the target nucleus, and it will not that it will hit or it will be absorbed totally. It will just hit and come back, or it will hit or some portion of it will be heated by that target nucleus, and it rest of the thing will come back. And in that direct nucleus reaction there will be no composite form like thing, like only just it will go and come, it will go or absorb, or it will go and come, something like that. It will be directly, it will direct heat and it will direct heat and come back, or it will direct heat or scattered back and something. So this type of reaction will be direct reaction. So in that direct reaction, high energy projectile should be there. High energy projectile should be there because if the energy of the projectile will be very less, then it may be possible that all portion of that projectile will be absorbed by the target, and there may be a possibility of make a compound reaction. Okay, because compound nucleus means a composite form of the two nucleus. So direct reaction should be here when the high energy projectile will be there. So if the high energy projectile will be there, so that means just go and hit, or there will be some reaction between target and projectile, and it will be come back. This is the main property for direct reaction. And obviously I told you that it will be very short lifetime, like just go and come back. So that means 10 to the power minus 21 second will be there. It's a very small time nuclear reaction. So if I go to the example, then it will be very clear to you that what is basically exactly direct reaction. So if I take an example, let's say one example, that it is known as inelastic nucleus scattering. Okay, inelastic nuclear scattering. So in that inelastic nucleus scattering, what is there? Like let's say here one X is there. I am talking about capital X, just keep in mind that capital X is the target nucleus, and here one small x is there. So small x is there means like it's a projectile. So what it will be, like let's say it will go and hit the target nucleus. When it will hit the target nucleus, then what will happen? Like as it is a direct reaction, the time of that interaction will be very small, 10 to the power minus 21 second. So as a result, what it will be, it will just interact with some of the nucleons present in that target nucleus, which is present at the surface of the target nucleus. So let's say as a whole, this is the target nucleus, and in that target nucleus, let's say outside of the target nucleus, at the surface of the target nucleus, some nucleons are there. So basically what small x will do, small x will go and it will affect or it will interact with that surface nucleons, and it will come back or it will absorbed by that surface nucleus, and all these things will be happen. But it will not go inside of that capital X. It will interact with the surface nucleons of that capital X. I am talking about the main thing here. So in that direct reaction, the reaction will be from the outside out core, like out cell of the target nucleus. There will be no interaction between the inner cell nucleons of target nucleus with the projectile. So this is an example for direct reaction. And okay, so this is an example for a direct reaction, which is known as inelastic nucleus scattering. So I am talking of the second example. This second example you can understand very easily. Deuteron stripping. Sorry. So what is deuteron stripping? Deuteron stripping means, let's say there is a target nucleus and there is a projectile. In that projectile, I am taking projectile as deuteron. So you all know that deuteron nucleus is made of one proton and one neutron. Okay, so deuteron stripping is written like that, or it may be written like that. Okay, so deuteron stripping is there. So what is deuteron stripping? Deuteron stripping reaction means that in the projectile is D. D means the deuteron is composed of proton and neutron. Now what will happen, that among that proton or neutron, let's say neutron will go to hit the target nucleus and proton remains as it is. So what will happen, maybe it may be possible that target nucleus totally absorbed neutron, then it will make, like it will be one different nucleus as a residual nucleus, and the outgoing particle will be proton. So this is a deuteron stripping, and it is also a direct reaction. Why it is direct reaction? Because not only the whole deuteron is absorbed by the target nucleus, some part of deuteron is absorbed by target nucleus and some part left back. So this is a example for direct reaction where deuteron will be the projectile and the outgoing particle will be proton. proton is obviously that proton which come from deuteron nucleus. Is it understand? So this type of example is a direct reaction where deuteron stripping is there, and the reverse process is also a direct reaction. Reverse process means pickup reaction. In that pickup reaction, what is there? In that pickup reaction, the reverse process is basically there. Here is X, and okay, let's say here is a proton. So proton, and then outgoing particle will be deuteron. So this is a pickup reaction. It is the inverse of deuteron stripping. So this type of thing is also a direct reaction. So now these two main example of direct reaction. Now if I want to say that what is the reason behind the direct reaction, why that type of things will happen. Okay, so let's take a example of deuteron stripping as a example for direct reaction, and I am going to talk about why deuteron stripping will be there in any nuclear reaction. So basically what is there in that deuteron stripping? D is there as a projectile and target nucleus is X. Now let's say, okay, so we are talking about target nucleus. So target nucleus means nucleus is basically made up of proton and neutron. Like there are so many protons and there are so many neutrons inside the target nucleus. And deuteron is also made up proton plus neutron. Only one proton and one neutron. So it may be possible that this type of reaction will be there when there is a interaction, there is a electromagnetic interaction between target and projectile. Let's say electromagnetic interaction means what? Here the charged particle is proton. The charged particle is proton means it is a positive charged particle, and neutron is a neutrally charged particle. So neutron does not participate in any electromagnetic interaction, but proton does. So here inside that capital X there are so many protons. So now when a high energetic deuteron will come, high energetic deuteron means there will be one proton and one neutron. So that one proton can be there will be a interaction, there will be electromagnetic interaction between this proton and the proton present in that target nucleus. So there will be a repulsion between these two protons. As a result, the proton of deuteron will be left back, and the neutron, as it is a neutrally electromagnetically neutral particle, then it will go to interact with the target nucleus, and it will form a absorption of target nucleus, and it will absorbed by the target nucleus and become another new particle as capital Y. So this may be a reason for direct nucleus, like electromagnetic interaction between all the nucleons. But there may be one question here, that if electromagnetic interaction can explain that reaction, that X, D, P, Y. But in that second case, X, D, N, Y, this is not the case for electromagnetic interaction. In that reaction, what is there? In that reaction, neutron as a left back particle and proton of deuteron will absorbed by the capital X to form capital Y. So it is obviously not the electromagnetic reaction. Like if I am talking about the electromagnetic reaction is the main reason for direct reaction, it will not be the case for the second one, right? Because in that second one, if I am talking that an electromagnetic reaction will be present, then obviously you will tell that proton and proton will repulse each other. Then how can a proton be absorbed by the capital X to form capital Y? So yeah, obviously electromagnetic interaction will not be the case for second one direct reaction. For the second one, there will be one statement. There may be one statement. What the statement will be? The statement will be like that: like the capital X and deuteron. So part of the deuteron can be interact with that egg, with the nucleons of eggs, depending of the matter going here. Like I am talking exactly the same statement what it is written here, that what is the reason behind that thing. The reason is, yeah, actual reason is stripping take place due to the actual contact of one of the constituted nucleons of the deuteron with the nuclear matter. Like it is a actual contact of one of the constituent nucleons of the deuteron. Constituent nucleons means either proton or neutron of the deuteron with the nuclear matter. This is the main reason for direct reaction. So it may be possible that the reason is electromagnetic reaction, that's why we are getting the first type interaction, or it may be something else which will give the second type of reaction as a example of direct reaction. So this type of things is there. Okay, now I'm going to say about the importance of direct reaction. Like why should I read for the direct reaction, and direct reaction will give us what is the importance of direct reaction? The importance of direct reaction,
Excuse me, madam. Sorry to interrupt.
yes,
Can we discuss some examples? Not
yes,
direct examples,
yes.
compound, elemental examples. For example, we will directly make deuteron react with the copper or something else.
Copper, okay, just a minute.
Copper or something else, whatever it is.
Yeah. Then, like, what is?
Yeah, I'm asking just for example, we will make a direct reaction
Yeah,
using the
like,
actual compounds rather than this X and Y.
yeah, X and Y is a in general thing. Okay, like
The
X may
notation,
be
yeah,
any.
that's the notation. But I would like to get some examples.
Yeah,
For
sure.
example, we will make react copper with the deuteron, and what will be the resultant?
Okay, what will be the resultant? Okay, just to do one thing here. Copper. Let's say copper. Like as you were talking about copper, so I am taking also the copper. So let's say copper. What is the copper Z and A? Do you know?
It is 2963. 2963.
Yeah, like 63, 64, whatever it is, depending on the
Yeah.
isotope, obviously.
No, that is an isotope.
Yeah, and D means what? Do you know? Like
Basically, we hit it by some deuteron. It's not deuteron stripping. Basically, we have to hit it with the deuteron.
yeah, deuteron. So deuteron is like that. So deuteron in a deuteron stripping, what will be the outgoing particle? Like it will be proton or neutron. Like as I already
Proton
told
or
that.
neutron.
Okay,
Yes.
let's say it is a proton. Like if the electromagnetic interaction is the main reason for direct reaction, then proton is there and the outgoing particle will be there. Now the main thing is that what will be the outgoing particle? You can say the outgoing particle through that Z and A calculation, right? Like here proton means 1 is there, right? So
Yes.
yeah, so deuteron means what? Deuteron is nothing but a nucleus of proton and neutron. Like one proton will be there and one neutron will be there. So the mass number will be what, and the Z number will be what? Depending on that, we can have the value of Y here, right? Just to
Yes,
conjugate that Z and A in that nuclear reaction. Now the
Yes.
the main question is it possible to have a direct reaction or not? Obviously this type of question is totally depends on some type of parameters, like what is the energy of deuteron. It may be possible that depending on the energy, it may be a direct reaction, it may be a compound reaction, depending on the energy of the particle. So if the energy of the deuteron is very high, then it may possible to have a direct reaction, right? And and also not only that energy, like outgoing, depending on the depending on the angular momentum conservation, depending on the parity conservation, all the things we should note into the things to have a direct reaction as well as to have a nuclear reaction, compound reaction, because we all know that in any nuclear reaction some terms should be conserved. Some terms should be conserved means it should be conserved by charge, conserved by energy, conserved by angular momentum, conserved by linear momentum, conserved by parity, conserved by isospin, and all these things should be there. So depending upon all the parameters we can say that okay, it is possible as a direct reaction. Like direct reaction, if we have a example then we can discuss about the direct reaction, that if it is there or not, and how it evolved, and how the direct reaction is come into play, and why it is coming like that. We will do all the things, but obviously there are so many things behind that condition, that okay, only the charge and quantum number and energy will be conserved. It is not like that. There are so many things we have to take into our mind to have a nuclear reaction. If all the conditions will be satisfied, as well as if the direct reaction condition will be satisfied, then obviously it will be a direct reaction. Like you can also make a direct reaction, obviously by hand, not by experimentally, because as I already told, you are talking about copper, then deuteron, just add these things as a Z and A combination, and there will be a outgoing particle as proton, then what will be the outgoing residual nucleus, you can also tell, right, depending on the Z
Yes.
and A calculation.
Yeah. Yes. Actually.
So like and also if there is one reaction where y is missing, like you are asked that what will be the y for a direct reaction. If it will be direct reaction, then what will be the y value, then you have to just calculate that Z and A values for the initial case, and you can say that okay, as outgoing particle is proton, then what will be the value of y, we can tell from the direct reaction calculation. This is like that.
Yes. Yes. Thank you.
Okay, so now I think it's already 45. Oh, I thought that there will be so much time. Okay, so we will skip the calculation here for direct reaction. There is a simple calculation for direct reaction, but I think I should skip that. Like I am talking about the final result of the direct reaction, like direct reaction importance. Okay, what is the importance of direct reaction? Let's talk about one direct reaction, as you already told me that let's take an example. I am taking an example. Okay, the example is this one: oxygen, then deuteron, then proton, and then again oxygen. Is it possible? Yeah, obviously it is possible, because oxygen 16 is there. Just calculate all the Z and A calculation here, then it will be a direct reaction. I am taking this from a book, so that's why it obviously will be. Okay, so here the main thing for direct reaction is that from that direct reaction, from that deuteron stripping, we can understand what will be the value of IP for that outgoing particle, for that residual nucleus, only depending upon the deuteron angular momentum number. So what I am telling, see here oxygen 16 is there. If I am taking about the cell model configuration, then the cell model configuration of oxygen 16 is IP, which is 0 plus. You can also check by taking the cell model configuration here. I am not doing all the calculation here, but it should be 0 plus. Okay, the ground state configuration. So if it is 0 plus, now coming to the like IP and nuclear reaction is like that: oxygen 16 plus deuteron, and it will go as, why it is not writing, proton plus oxygen 17. So depending on the deuteron L value, we can have the knowledge about what will be the IP of oxygen 17. How? Okay, how means what? Like here like oxygen 17, as oxygen 16 is 0 plus, So, and proton is obviously it is a half like spin half particle. So depending upon the deuteron IP configuration, we can say that what will be the configuration of oxygen 17 in that reaction. As we know that oxygen 16 configuration is IP equals to 0 plus. So just depending on the values of L, values of I for deuteron, we can say that what will be the outgoing particles configuration, in like nuclear configuration. So this may be one of the importance of direct reaction. Like just seeing on this direct reaction expression, we can say that okay, what will be the IP value for outgoing particle when our incoming particle is in a ground state, and
Hello, ma'am. Uh, your laptop battery is very low, ma'am. Please,
yeah, sorry.
it goes to
Oh, ho, 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 ho.
your
Sorry, sorry,
laptop
sorry.
battery is very low.
Thank you so much. Thank you so much. I totally, yeah, thank you. Now it's fine. Okay. I did not see that. Okay. So basically, this is the importance of this direct reaction. So I am not taking all the details of these calculations, that how do I know that okay, uh, this is the main importance of direct reaction. Okay, just a minute. So this type of thing is there. So now I am coming totally to the compound nucleus. I don't know how much time I will get, but okay, let's see. If a compound nucleus will be more complicated, obviously it is more complicated than direct reaction. So I think I should spend some more time on compound nucleus. So I think today it will not be completed. We will talk in next week also about the compound nucleus, because I think personally that compound nucleus is more important than direct nucleus. In not only in any competitive exams, but also in understanding any nuclear reaction at least. Only 10 minutes is left. Okay, so we will talking about right now compound nucleus. Sorry. Oh. So what is basically a compound nucleus? Compound nucleus, and what is basically compound reaction. Okay, so compound nucleus and compound reaction, if I write like that, then compound reaction is like X plus X. Just note that I am talking about capital X, small x, capital Y, small y, and all these things, and just be sure that I am writing this exactly right thing. Now this is the thing for compound nucleus, compound reaction, sorry. So in that compound reaction, what is there? The compound reaction means capital X and small x will interact, and it will form a new compound, which is, let's say, C star. Why I am writing C star? Because the compound nucleus will always be in excited state, and it will decay to another nucleus like capital Y with small y. This is the nuclear reaction expression for compound reaction. Now I am just talking a little bit theory of that. I think in that next class we will discuss whole the Breit-Wigner formula and Ghosal experiment and all the things. But right now I am just talking what is happening in that compound nuclear reaction. In that compound nuclear reaction, our capital X is there and small x will come, and obviously as I told you that small x will be low energy enough, like it will not be a high energetic small x, it will be a low energy projectile. It will be low energy projectile, so that it will just come to hit capital X, and as it is a low energy projectile, it may be possible that it will totally absorbed by capital X. Okay, now what will happen when, okay, let's say this is a capital X and this is a small x. Now capital small x will come and it will it will interact with capital X, right? And in that capital X there are so many nucleons. So let's say any one of that nucleon will be interacted by small x, the small x. Now what will happen? The small x may be totally absorbed by capital X. Totally absorbed by means that all the energy of that all the energy of small x will be absorbed by that capital X nucleon. Now let us say there are so many nucleons inside that capital X, right? Now any one will be interacted at first with small x. Now what will happen? It will happen like that. Small x will interact with one of the nucleon of capital X. Then this nucleon will interact with another nucleon. This nucleon will interact with neighboring another nucleon, and as a result there will be a disturbance between all the nucleons inside that X, right? And but there will be not that much enough energy for only one type of nucleon so that it can escape from the capital X. It is not the case. Like there will be a very disturbance between all the nucleons inside the capital X target nucleus, and there will be so much collisions between all the nucleons. Let's say in that book they are just talking about a numerical calculation that when the collision between all the nucleons will cover 10 billion times, then for each and every collision there is some energy will released, and if there will be, let's say, 10 billion collision is there, so that means there are huge number of energy will be produced, and huge number of energy will be produced so that one or two of the nucleons inside that capital X will be very energetic, and it will decay to capital Y and small y. Like it will be, let's say, escape from the small x from the target nucleus, and it will make another residual nucleus as well as a outgoing particle. So the main compound nucleus is which one? The compound nucleus is the case when small x is interacted, or small x is totally absorbed by the target nucleus. This type of state is known as compound nucleus state, where small x will be totally absorbed by capital X, and we will make a different type of nucleus which is known as C star. And why it is star? Always it should be star, because there is a disturbance between all the nucleons due to the presence of that small x inside that capital X nucleus. So this is the main thing behind that compound nuclear reaction, that there will be a intermediate or transition nucleus which will be known as compound nucleus, and this compound nucleus after formation there will be a very unstable state, and this unstable state obviously make one small y as well as a one capital Y to form a stable state, and we will have as a small y and capital Y for as outgoing particle, and initial particle was capital X and small x. So this is the theory behind the compound nuclear reaction. And obviously in that compound nuclear reaction there I am just talking about a very basic let's say very basic property, that how it will make, but it is not exactly the actual one which will found a compound nuclear reaction inside the nucleus. There will be one potential well, and in that potential well projectile will go, and there like in that potential well projectile will just move here and there will be a damped harmonic motion. In that depending on the damped harmonic motion we can have a C star, and then C star will break into small y and capital Y, and all these things will be there. So these things we will discuss, but I think in that next class we will discuss all the things. And also there is a Ghoshal experiment, and there is a Bread-Wigner formula for compound nucleus, and also it is saying that independence hypothesis is also there for compound nucleus. What is independent hypothesis? There is nothing worried about independence hypothesis. Independent hypothesis is like that the hypothesis tells us that C star, that compound nucleus, will formed by X and X, but after formation as C star it will totally forget about X and X. Like it will not depend right now how it formed. It will independently decay as small y and capital Y. It will not dependent upon how it was formed, and depending on that it will form what will be small y and capital Y. It is not like that. It will be a independence hypothesis. That means the compound nucleus will be a independent nuclear reaction, where compound nucleus will not remember that how it forms, and depending on that it will not decay what will be the value of capital Y and small y. It will be totally independent of how it formed. That's why it is known as independence hypothesis, like independence hypothesis for compound nuclear reaction. So all the things are there, and I think today I don't want to go into the like mathematical calculation for compound nucleus. Like up to this, if there is any question you can just ask about compound nucleus. I was not talking more about compound nucleus. I was just talking about very basic and very what not deep in compound nucleus. I will tell about compound nucleus in very deep in the next class, but right now I was just talking that how compound nucleus is forming, and what is the independence hypothesis and all these things. So if you have any question you can just ask me, or otherwise we will discuss all the things in detail in next class. Okay, as it's already 6 o'clock, so that's why. Like I will obviously do all the calculations and all the Bread-Wigner formula and Ghoshal experiment, then speciation in reaction and all these things. So I will do in the next class, so that it will be very clear to you what is basically compound nucleus is. But for today I think I will stop here. Is there any question? You can just ask me. Okay. Sorry, actually I thought it may be possible that you thought that it will be totally covered by only one lecture, but I don't think that it will cover only one lecture. So that's why I was taking 2 lectures for compound as well as direct reaction. And I personally think that direct compound reaction is very important for all of us, so that's why it will take some more time, and obviously the little bit calculation, little bit mathematical expressions will be there, so that means it will take so much time. So sorry for that. I was not covering in one lecture.
Okay, ma'am.
So we will do
It's
in
very
the next
helpful for
class.
me. I will.
Yeah.
Yes. Okay. No problem. It's very helpful for me. Actually, now I
Yes.
am now lots of questions I get clear. So I can when I read this, then I will get
Sorry, I can't
some
hear you.
knowledge.
I'm really sorry, but I can't hear you
I think.
properly. So, can anyone please translate
Okay.
what he is
Okay, ma'am.
telling? Maybe my internet problem, or maybe your internet problem. I don't know. Like, Mohammed, can you please?
I think there is a problem, network issue.
Mohammed, can you please explain what he is telling? I can't hear him.
Yeah, he just said this will be helpful for him,
Okay.
and
Okay.
the next lecture as well.
Okay. Thank you.
In general.
I don't know
Yeah, it was
how,
okay
I can't
until now.
understand, but you people can hear his voice, but I can't hear his voice. Sorry for that, but I really
No, basically it happens. No, basically it happens because you are involved in discussion, so those things happen.
okay. I thought my internet problem is there, but I am totally clearly hear your voice, but I can't hear his voice. Okay, it may be internet problem, whatever it is. So if there is no other question, then we can stop here and we will discuss in next class. Okay.
Yeah, thank you.
Bye bye.